Okay, so I think a lot of us are trickling in, so we can get started. Um, so for this class, like yesterday, I would prefer that if you can have your cameras on throughout the entire session, so I can get a little bit of reaction and see how you're doing throughout the class. Um, and I'm going to introduce myself. I'll be your instructor today. I'm Tina, and I'll be teaching class 2. Okay, I think before we get started on the new content, we can do the homework from we can go over the homework from yesterday. Okay, so everyone, you want to create a new Google Colab notebook, or you can build off of yesterday's, it doesn't really matter. So, um, can I get like thumbs up or anything if you've already gotten there? All right. So it also, if you have any questions, feel free just to open your mic and tell me, or just text in the chat. But I also prefer that you speak up because sometimes I might like accidentally miss the chat or for whatever reason. Okay. Okay, we can get started on yesterday's homework. So has anybody been able to do it? Or yes? No? Was it close? Okay, that's all right. We can go over right now. So the prompt for the people who weren't here yesterday, it was you want to make a program where somebody can input the first number, and then they also input the second number, and also ask them for the operation, either addition or subtraction you want to happen between these two numbers. So we can start. Okay. By asking, oh, okay. You can start by asking the user for the first number. So remember that when the user inputs anything, it's a string. So you want to convert it to a float because you can technically take a decimal number. So you want to use the float function and then the input function. And then the question, you're going to ask them to input your number through. So we're going to do first number for num1 and num2. We can do float. Also the same thing. And afterwards, you want to ask for the operation. So operation num1 and num2 are basically the variables in which you will store the user's answer in. Some review content from yesterday. So you can ask them to input maybe like plus for addition and minus or subtraction. That should do. And then, one concept that we learned yesterday was the if function. So there are two possible things that can happen, either subtraction or addition. So if operation, remember we have to do equal equals instead of equals because it's programming, not math. And then we can print num1 plus num2. But if the user wants to do subtraction, so if that's what they input for operation, you want to print num1 minus num2. All right. Does this make sense for everyone? Okay, cool. It's gonna take some time to connect to the back end of Google Colab, but all right, so the program asked us, we can do maybe first number 1.2, a float, and then second number 4.5. And then we can do addition. All right, 5.7. That looks like the right answer. So, does anyone have any questions for the homework from yesterday? Can Nope. Okay, we all know how to do it. Cool. Let me just label that real quick. How? And today, starting with some new content, we're going to do lists. So lists is another type of complex data structure for Python. There are 4 in total, and list is the first one that we're going to cover. So list is an ordered, mutable collection of items. List can hold a mix of data types, including integers, strings, and other lists. So, and floats as well, whatever there is. So how to create a list? This is the syntax. So you want right here the list name is a sign, which is the equal sign to, you want square brackets around the content or the list of items you want in the list, and basically all the items you want to put in the list separated by commas. So we have integers like 1, 2, 3, and also a string like apple. Okay, so for example, if I create a list called num list with a bunch of numbers, essentially this is what it really looks like. So like 1, 2, 3, this entire like block of thing is the list dedicated to it. List is like a container for a bunch of stuff. And also, if you want to create an empty list, you can just put list equals square brackets. There's really nothing in it. It might sound like weird right now, like why would you create an empty list? But it can be useful in the future if you want a list and then like start adding stuff to it in the future. Okay. We can go back to our code so I can show you guys some examples of list creation. So we should use pseudocode all the time or comments to keep track of what you're writing. So you can create something called a num list with a bunch of numbers, like 8, 9, let's go up to 9. Okay. And then simply just to see what the list looks like. Here we are, just a list of numbers, or you want to create like a string list. That's gonna take a bit more time. Like dog, cat. It's the example we had from the slides. Apple, key, etc., etc. And there's more. And then so as easy as that, you just put list equals square brackets and contents inside. And if you ever want to checking the length of the list. So basically how many elements you have in the list, here's what you can do. You want to use the length num list. Like if I want to see how long the number list is, just do this. It'll give you the name. So we can try printing it. The length of the list is, so here we go. Oh, we want a closing bracket. So the length of the list is 9. So that's true because we have 9 elements in it. All right, any questions so far? Nope, okay. Then we'll go on to the next part of lists, which is indexing. So after you create your list, all the contents are placed in different positions or indices in the list. So for example, the num list that we had from before, 1, 2, 3, 4, 5, 6, 7, 8, 9, the matching positive index, let's go to this row, is 0, 1, 2, 3, 4, 5 through 8. So we want to watch out, something that we want to watch out for in programming in general is that usually all indexing, well, starts at 0, and indexing for lists, tuples, or dictionaries, which we'll cover later, all start with 0. So the first element of the list starts at 0. And the reason for that is the index tells you how far away you are from the first element. So if you're at first element, of course, you're 0 distance away from it because you're right there, right? So that's how you do that. And then we also have negative indexing, which goes backwards. So wait, I can demonstrate to you how indexing works. Wait, also before we do that, like I did mention in the last slide that you can initialize an empty list. I can just show you that real quick. It's very quick. Empty list equals empty list. And then we can print. Yeah, so it just shows an empty list. I just want to show you to be clear on the syntax. Okay. And we can do, okay. So we had a num list above, right? Right, make it visible to everyone. And then we can create a variable called first element, where we want to extract the first element of the num list. So how would you do that? Can anybody like either tell me in the chat or unmute yourself which index I should put according to what I just talked about to get the first element of the list? Right. That's correct. We start from 0. It's good. Oh, sorry. We should print it to see. First element. And we also talked about going backwards, right? So why is there like positive and negative index? Like it's just pretty redundant. But the thing is, when you know when you have a really, really long list, for example, you don't really want to count off to the very end if you want to fetch like maybe the last or second to last or third to last variable. You really want to have like a faster way to get to them. So you want to, if you ever want to start backwards for some reason, you will go from -1, -2. So when you start backwards, remember we don't start from 0. It's not like positive. We start from -1. So, okay. Um, if we still want to get the first element, but using a different index, which is the negative index, which index should we use? So there's a total of 9 elements in it. And share in the chat if you know. And try counting backwards from -1, if we still want the first element of the list. Okay, if we're not sure, that's all right. I can walk through. So we have the num list right here, right? So we go from -9, so we want to do -1, -2, -3, 4, 5, 6, 7, 8, 9. Okay. Good. Somebody said -9. That's perfect. Yeah. So it would be -9. So let's see if it prints the same thing as the one we used before. It should. 1 and 1. Perfect. So those are the elements in there. And then, yeah, this is, let me make a quick note here, negative indexing, right? Okay, then what if y'all do like a quick practice? So what if I want to get the element, let's say apple from the list, string list. Can you give me 2 different indexes or just write out the code with 2 different instances that will give me the same element, apple, with 2 different indices. After you finish your code, you wanna like private chat to me so you like don't send it in the group and everyone can see it. So I'll give you like maybe a minute or 2 because it's pretty quick to work through that. Oh, we already got one. That is correct. Wait. Mm-hmm. Oh, what were we supposed to do? So basically, you want to print the element apple from the string list, using indexing. You want to do positive indexing and negative indexing. So negative from backwards counting and positive from, I guess, forward counting from 0. And apple is here for your reference. Okay. So I got a response in the chat about having an error. So I can go over why there is an error that happened with this code. Um, Here. So few things to talk about. Um, First of all, num list. You want to use, okay, sorry, it's my bad. I forgot to mention, but when you do indexing, you always want to do square brackets. Never use the round brackets. Um, it's indexing for everything, lists, dictionaries, and everything. So that's the reason why it's going to give you an error message. So let's see how this works now. Perfect. So I think we can use the same logic to get to Apple in string list. String list. Okay, I got a response in the chat. Okay. So we can use what they said here. So we can call it maybe like string first, a different element name. Okay, string list. And the first index that they gave was 2. Oh, string first. And then let's call the second variable a different name. String, we can do negative, string negative. And then they put -3. So, and string negative, that's right. If this will run correctly. Okay, so the first one did give us apple, but the second one returned us cat. So why is the reason -3 wrong? Because we remember when we start backwards, we want to start from -1. We don't start from 0. So -1, 2, 3, that gives us cat, and we want apple. Therefore, the correct answer to this should be -2, also from counting backwards. Okay. Um, does anyone have any questions with indexing either positive or negative? Are we good? Okay, then I think we can move on to the next section. Oh, I'll get rid of this tab. Which is slicing in lists. So um slicing is also pretty straightforward. It's just creating, if you want to create a new list with only parts of the list, you give the indices of from where to where you want it. But there's also one thing to watch out for. The First of all, let's go over the syntax. Okay, so we want square brackets, and the first index is where you want to start. It's inclusive, meaning it will include that element at that index. And then you want the colon, and then followed by another index. But the catch is that the back index is actually exclusive, so it's going to end at the element before this index. So I can show you guys what that means. Um, so let's do slicing. Okay, let's call it my list. We can do numbers again. And then for instance, we want a sublist created that only contains, or actually, we can, does anyone know, sorry, it has to be my list. So the original list followed by the slicing index, and then the new list, which contains those elements. So does anyone know which numbers from my list will sublist contain? Um, can just quickly answer in the chat or Okay, somebody said 2, 3, 4, and that is correct because um 1 is inclusive. So 0, 1, which is 2, um, and 3, so all the way to the third element because 4 is exclusive, so we end at the third element. So 1, 2, 1, 2, 3. Okay. All right, that makes sense. So I mean, I can run it to show you. Okay. Also, I just got another question in the chat. So when we name our variables, which is it's a great question, like why do we use underscores? Um, because because um you can't use instead of spaces because you can't use spaces. So, you want like one single string value to be the container for your item. So as you can see, let's see. See, invalid syntax. That's what will return to you if you try to use a spacebar in the middle of your variable assignment. So usually programmers what they try to do is either they do underscore or they do capitalization. For example, like this, my list. So you can tell it's like 2 words, but it's still technically 1 word. All right. I hope that answers your question. And okay. So for slicing, let's see, we can do a quick exercise. So when you're given a list that goes from 1 to 20, um, first first thing you want to do is extract using indexing, slicing, extract the first elements into the list called first five, and then extract the last 5 elements into a list called last 5, and then the elements from index 5 to 10 inclusive to the middle section. So this is pretty much already written code. All you really have to do fill in is like at the red parts, you want to do the slicing. So I'm going to send this code into chat. Um, and then you can just modify my red highlighted parts. And then once you have the answers, direct message it to me again, and then I can see if it's right. Okay, I'll probably give you like maybe 5-ish minutes to work through these 3. Let me know if you have any questions. So, look, we did end up getting. So, what's different is the second code. So, 15 to 21, it also works. So, you just count forward. Very good. So, you can do negative or positive. So, good job. That also works. Um, mm, how would you write number 2 using number 2? Do you mean this one? Last 5? So this is how I did it with negative index. So I just mentioned, so if you don't put anything like right here, there's no number following the colon, right? That means just to go until the very end. So if it says last 5 elements, so we count backwards, 1, 2, 3, 4, 5. So -5, that's our starting point. And then since we put nothing for whatever follows the colon, that'll go till the very end. Does that make sense? All right. And some people might have joined a little late, and I don't think slicing would affect what we learn later on. So if you need help, I can stay a little bit after class to help you catch up with slicing. But otherwise, is there any question related? Everything from range to negative, positive indexing. Make sense? Okay. All right, then we can move on from actually let's do a little bit of practice to solidify like um our knowledge on this skill with indexing. This does not require slicing, so it should be all right. Let me send you guys the link to coding bat. All right. This is right. So you can find the same page as me, and you can start really like working on this, and then um we're actually probably going to cover this one and the next one. So if you finish the first one, go on to the next one, because I'll give you guys like 5 minutes for the first, and then after 5 minutes I'll like go over this, and then we'll do the next one. Okay, so I got some responses in the chat of people who already finished the first one and also moved on to the second one. So um we can start by looking at the first one. So the prompt is given an array of integers, return true if the array is length 1 or more and the first element and the last element are equal. So there are two conditions that we have to satisfy. And when you have two conditions that both must be met, remember from yesterday's lesson about like and or operators, we have to use and because both conditions have to be met. And since there is a condition, what we use is the if statement, right? So if something is true, we do this. If not, this happens, right? So we can do starting with if. So the first condition that we have to meet is if the array length is 1 or more. So we use the length function like we said above. So, and nums, remember, look at here, nums is the list that they're giving us. So length of nums, if it's 1 or greater than or equal to 1. Okay, that's our first condition. And the first element and the last element are equal. So what did we say about indexing the first? So remember, the first index is always 0, right? So equal to the last element, which is oh, sorry guys. Remember to use brackets, square brackets. That is very important. -1. If this happens and that happens, we return true. If not, else. Else is like, if this doesn't happen, this will happen. Like the else will happen. Return false. Let's see. All right. Does this make sense to everybody? Any questions about the first one? So 0 is the first element indexed at 0, and -1 is the last element if negative indexing starts backwards, right? So it's the very last element. So if they're equal to each other and the length of the thing is either greater than or equal to 1. Okay, since some of us already move on to the second one, I'm wondering, are we like finished or either stuck on the second one? Should I go over the second one as well or more time? Okay, then maybe, oh, and move on. So this one is return an int array length 3 containing the first 3 digits of pi. Okay. Wait, sorry, did I go over the second one first on accident? Sorry. Okay, I'll go over the first one right now. So return true if 6 appears as either the first or last element in the array. Okay, so again, we want to use indexing again. So if 6 is equal to, okay, nums is also the list that they gave us here, right here. So index either the first element, remember, is always at index 0. If this happens, or. So this time it satisfies either of the conditions. It doesn't have to satisfy both. So therefore we want to use or. Last element is always -1. So this will return true. If that doesn't happen, then our alternative is to return false. Okay. Okay. So, do both of these problems make sense to everybody? Any questions on indexing? Okay. So after indexing, we're gonna go over some uh like list operations. So I think for now, it's like almost 8, so we can go on a 10-minute break and then let's reconvene after this. And all right. Right. So I think we can get started with some list operations. Okay. So the first one that we have is append, one of the most used one. So append basically adds any like single elements to the end of a list. So for example, we have the list 2, 5, 6, 7 here, and I want to add the number 8 to the list. What we do is just list the list to which you want to add something to, dot append, and then the element that you want to add to the list. And then print list just to really see what it looks like. So here's the syntax. Can do example here on Colab. So, pen. And it's important to remember that it only adds one element. It can't add more than one with this function to another list. Okay, so let's create a list called list. And then we have the numbers 2, 3, 4, 5. And then we want to append, for instance, number 6 to it. Here's how we would do it, right? We can run it. I just said earlier that we can't add like more than one number to it. Then let's see, what if we try to do it? We can see what it will do to the list. So we can create another list called list 2. Since we already ended on 6, we can start from 7, 8, 9, and okay. And then we want to add these numbers to the list, the first list we created. So list.append. We try to add list 2. Let's see what it'll return us. Okay, so rather than adding 7, 8, 9, 10 as individual elements, you see what it did? Like after the comma, after 6, we have another list. So basically, like list is seen as its own element and added to it, rather than like the numbers in the list too, right? Okay, so what if we do want to add many different elements to an existing list? We would want to use the extend operator. So the extend function. So this extend function adds items of an iterable. So an iterable includes a list, a set, a tuple, and really stuff like that to the end of an existing list. So for instance, the the example right here is cars and then other cars. So if you use the extend function on cars to add other cars, you will get one big extended list. Can do here the example that we were working on. Let me make a note. Extend operation. adds individual elements from an iterable the end of the list. Okay, so this is a very important distinction between the two. So we can recreate the list again. Oh, forgot. List 2. So if we wanted list 1 to also contain the elements of list 2, what we would do was the list to which we want to add stuff to, which is list, dot extend the function, and then elements from list 2. And grant list. Now our list should contain, you see, individual numbers rather than a list of numbers. Okay, that's how you would work with extend. These operations not only works on numbers, they also like work on strings, and it's not only lists that can elements from lists that can be added to another list. I know that sounds kind of confusing, but there is another data structure. We haven't covered this yet, but it's all right. All you have to know, it's different from a list. It's not, you see, it uses round brackets. It's called a tuple. And then a tuple is also an iterable. Therefore, you can add elements from a tuple to a list as well. So the extend function can really add anything from iterable to list. All right, okay. Any questions on append or extend so far? Okay, can always let me know if you do in the chat. Okay, so now we have the pop function. So we've covered two operations that can add stuff to a list. Pop is used to remove something from a list. So it removes and returns the last value from the list. Oh, it removes the value at which you give the index to. So for instance, look at the example on the right. Fruit, we have a list called fruits, and then if you do dot pop and then the index is 0, located at index 0, we have apple. Therefore, it removes apple from the list and returns mango and cherry only. But if you see on the left, if you don't give it an index, if you just put dot pop, it'll remove the last element. It's just automatically doing that. It's like a Python thing. All right, we can do so pop. Um, our final list looks like this, right? We have this thing, and then we can do list.pop. What should we remove? We can remove Jonathan. Okay, we can remove Jonathan from the list, which is at index 5, right? So if we do that, it'll give us everything except Jonathan. And if we want to remove hello from the list, we can do just dot pop. Oh, remember yeah. See, now that removes the last one because you didn't specify which one you wanted. All right. Okay. And then, okay, here's something we can do an exercise. So we have two lists. It'll incorporate all the things, all the three operations we just covered. So first, I want you to combine the two lists into one and add the number 10 to the end of the combined list and remove the extra 3 in the combined list. As you can see, there's an extra 3 in here. So as you work through it, send me the code and then so I can know where you guys are at and whether Are there any common mistakes that we need to watch out for? Okay, I'll give you like maybe 4 to 5 minutes to work on this one. All right. I think we can maybe go over this and take your time as needed to work through it. But at least we can go through the first part of it, which is adding list two to list one, right? So, if you want to add individual elements from an iterable, which the list is, you want to use extend, right? Append only adds one, but the extend adds everything. So we can check if that does the job. Good. So it adds everything to list one. And following that, we wanted to add the number 10 to the end of the list. So now our list one dot append number 10. That's very simple, just like that. Yep, and now we have 10 from it. So we wanted to remove 3 because we have a repeating in the list. We can use pop, right, to remove. So it's at a specific index at 0, 1, 2. Or you can do 3 if you want to remove the second 3. It doesn't really matter, but just remove one of them at the given index. List 1. All right, that should be our final list. Okay, that makes sense to everyone? And let me know if you have any questions. All right, we're going to cover tuple like really quickly. It's not like super important in regards to what we are learning, but it's it's good to know because it's one of the 4 data types specific to Python. All right, not specific to, but like built into Python. Okay, so tuples is very similar to a list. It's ordered, immutable collection of items. Like list, tuple can contain a mix of data types, meaning you can have integers, floats, strings, here. And the syntax, the only thing that differs from a list is that it uses the round brackets rather than like a square bracket. So why is it that you have 2 things that almost do the exact same thing? So the only thing that differs from lit tuples differs from lists is that it's unchangeable. I can give you guys an example. So tuples. So let's just create a tuple really quickly. Like everything is the same except for the fact that you're using round brackets. So we can do 1, 2, 3, and then maybe like let's use some strings like apple, banana, and yeah. So maybe I want to exchange an element. So mm, okay, let's create a list first. We want to do a comparison, so let's also create a list. The same thing inside. So if you were to modify a list, for instance, you want to change banana to orange, you would do my list, what is the index of banana? It's -1, right? So we can do -1 equals, we want it to be orange. Okay, we can check what the new list looks like now. See, now banana's changed to orange. So that's the thing about lists. You can modify what's inside it. But on the other hand, my tuple, if you try to do the same thing with the indexing and assigning it orange, it's going to give you an error message. It's going to tell you that tuple object does not support item assignment, meaning that you can't change what's already been created. So whatever you put in the tuple, you can't change it at all. So why would you even want a tuple in the first place then if you can have a list which is which pretty much does the exact same thing, and you can change it. The reason is that because the fact that the list can't be modified, it needs to take up more memory storage from your computer, and therefore it takes longer to run. Well, as of now, we have really, really small tuples and lists, so there won't, it's like milliseconds difference, so it won't really be that dramatic. But when you do like large programs with like millions of data sets, it will make a difference. The time it takes to create a tuple will be much shorter than it does for a list. Okay, so that's pretty much for tuples. Not much difference, but it's just unchangeable. Okay. So then we have iterations. So this is one of the most important parts of programming in general. So there are two types of iterations, two types of loops. One is called for loops and one is called while loops. So iteration is the process of repeating a set of instructions for either a specific number of times or until a specific condition is met. So for loops in general is used when you know how many times the loop should be ran. And while loops is when you want the loop to break based on a condition. Okay, that might sound kind of confusing at the moment, but we can look at the flowchart. So you have an if statement right here, like last item, like basically you assign, for example, I want this code to run 5 times, and then it's going to check, is this the 5th time? If not, then you run that code again. You go back. And then if it did reach number 5, the 5th time, it's yes, then it exits this loop of code. So that's for loop. While loop is when, for example, I want the code to keep running until we find the element apple, for example. So it keeps iterating through the list until it comes across apple. You don't know how many times you need to because you don't know where apple is located, but you know it needs to find apple. So this is when you have a condition that needs to be met. So that's when you use while loops. Meanwhile, for loops is you know how many times it should be ran. Okay, so now that I know this can be very confusing at first, but any questions on like the loops, when to use them in general? We'll cover the syntax like in a bit. Are you good? All right. Okay, so for loops. So here's the syntax. You start with the word for, pretty straightforward. Like for basically tells you for how many times. Like define a variable that will take the value of each item in the sequence. I think it's easier to explain through code. Let's just go to code and then we can combine it with the slides to explain. Um, Iterations and then for loops. Let's think of a prompt. I think for loops. Okay, finding the average height of the class. This is something we can do with a for loop. Um, let's create a random list. Maybe. Okay. I want to make it long enough, but okay. Maybe this. Okay, that's very short. That's some heights of students in a class, and then maybe we want to first let's initialize a variable called total height. We initialize it to 0. So syntax for a for loop. You know how many times you're going to iterate through because you know how many people are in your class, right? So for I, so this is the for in range name. Okay, let me finish writing the statement and I'll explain what all this means. Okay, so we have length. This is a familiar function that we've covered above. So the length of this list. So student heights, length of student heights. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this length is 11. So in the range of 11, it's going to iterate through the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because why? Remember range, I talked about it being exclusive, so it's gonna end at 10 rather than 11, and it starts at index 0. So basically range 11, and it's for I in range. I is every single time it iterates through the numbers. So for instance, the first time I will be equal to 0. The second time the I will be equal to 1. The third time equal to 2. So does that make sense? So each time it increases one number until it reaches the range number, starting from 0. Okay, so if we know how many times we're going to iterate through, because that's equals. So every time we iterate, what do we want to do? We want to update the total height, right? Wait, sorry, this is student heights because that's the list name, right? Plus. I'm not sure if you guys have seen this syntax yesterday, but this also might look confusing because like how can you have total height equal to total height plus something else? That just mathematically doesn't make sense. But in Python, what it means is student height at index I, remember for loop, we start at 0. The first time it's 0. So student height, 0 element is 142. You add it to total height. What is total height? We assigned it 0, right? So 0 plus 142 equals the new total height. So that means we're updating the variable. We're not actually saying that they're equal to, but we're assigning a new value to it. That makes sense? Okay. If any question comes up along the way, just let me know. And then, okay, then we can talk about the loop again. So now we were at I equals 0, but it hasn't really met 10 yet. So it has to keep looping the same thing. So from 0, it goes to 1. So at index 1, what do we have? 150. So student 1 will have 150, 150 added to 140, because that was our latest updated total height, right? So 150 plus 142. And the next time we add 137, and the next time we add 145 until we get to index 10. And then it tells it we have already met the range. Does that make sense? Okay. Then average height. Because average is just dividing everything added together. Oh, do I have code? Okay. It's just dividing everything we have by the number of people there are, right? That's an average. So that's the operation that happened above. Uh, so, okay, so this is the average height of all the students here. Does this make sense, or should I go for a simpler version of explaining what a for loop is? I can, for example, like for I in range, we can give a number. Maybe range 10. Okay, we can have it print I. Let's see what it does. Right? This was what I was talking about. So in range 10, we go from 0 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 10 numbers. And then every time we're inside the loop, it performs the function. So print I. So we're at 0, so we print it. And the second time is 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope this breaks down at least like the iterating part of it. Okay. Are there questions? Confused? Or understand? Or anything? Okay, are we good? Okay. Then let's see. We have, oh, sorry, we do have some questions from the chat. Oh, yes, the average height a student is, I think. Ian, did you have a question? What was your question? How does it know whether to add 1 to I? Okay, that is a great question. For loops, it's designed to increment by 1 every time. So, because usually when you loop through something, like for example, indexing, you're not going to use like 1.5, 0.5, or any like non-whole numbers. So for loops are designed to increment by 1 every single time. Okay. All right. Then I don't see any other questions. So I think we can move on to while loops. Okay, I think in a similar situation. Okay, let's start with a simpler example. So let's set I equal to 0, for instance. So we want while. This is the syntax. So for loops start with for, while loops start with while. So while the I is less than 10, we want a certain action to keep repeating. So until it meets the condition that until it breaks this condition, the thing inside the loop will keep iterating. For instance, we can do I equals let's do print I first. And then print I. So the previous question was about how does the for loop know to increment by 1? Because it does, but the while loop doesn't know. So therefore you have to update the number by yourself. So I equals I plus 1. So we want it to increment by 1 every time, or you can increment by 2 if you want to. So here is what it'll look like. Oh, wait. I equals oh, sorry, I put 1 there. It's supposed to be I. Okay. You see? So it stops at 9. So the reason it stops at 9 because when we updated it to 10, it already printed 9. So when we get to 10, it's not going to be able to pass the while condition. So it's not going to print 10. Okay. So this is a simplified version of how a while loop works. Any questions about it? So this is based on a condition, right? No questions? Okay. Then another example, like a real life situation might be like using the okay, we can copy this over. Using this we already created above. Maybe we want to find a student that's, let's see, taller than 152. So how are we going to do that? So pretend that we don't know where the student like is located in the list. How are we going to know how many times to iterate through? We don't know, but we do know the condition is that he has to be taller than 152. So we can set I equal to 0 because that's our iterating variable, right? So while student heights, so we're going for indexing again, is less than or equal to 52. Oh, this one. Print the student is found. Their height is, this is how we can check if it's actually right. So we want to print the student height. Okay, so the student is found, their height is 153. So 153 is indeed greater than 152. It didn't print anything else before it because yeah, none of those numbers are greater than 152. So 153 is the first element that breaks the condition. Does that make sense to everybody? Any questions? Okay, if we don't have any questions, then okay, we can do like a quick exercise maybe. Okay. So you want to write a program that categorizes a list of numbers into even and odd. Like you're given any list of numbers, and then um, you want to create two separate lists from that list that one contains all the even from the first list and one contains all the odd from the first list. Um, I think I can give you guys maybe 5 minutes to work on this, and I'll create a list of numbers for you guys to test your code. And here's a hint to approaching this exercise. Here. Think first if you're going to use for loop or while loop. Either do you know the number of times you're going to iterate, or do you know like the condition that needs to be broken or met, right? And since we're dealing with lists, think about list operations, like how do you add stuff to another list, right? This is slightly complicated, so I understand if anyone hasn't gotten to the point yet, but here, as you work on it, can at least go over the first steps. So we talked about creating empty lists before, like it seemed useless to that we needed to create empty lists, but here's when it comes in handy. So at first we don't really have any elements in the list because we don't know which numbers are even or odd, but as we iterate through each and check, we start adding them to it. So it starts out empty, but we add stuff to it as we go. So even or odd. And then using a for loop. So the first thing we want to do is to iterate through everything, right? So in order to do that, so I can call it by the way, you don't have to name your variable I or whatever. A lot of people do like I, J, or if you want to give it a name for clarity, you can. So I'm just gonna name it number in this case. So we know that we're talking about each number in the numbers list. So the list is called numbers. So for each number in the numbers list, um, if the number, so how do you check for whether a number is even or odd? So one thing, like a trick that we always use is to check if it's divisible by 2. So even numbers are always divisible by 2, right? Meaning that if they're divided by 2, their remainder will equal 0. So I think they covered this yesterday about the mod operator. So mod basically means if you divide this number by 2, what will their remainder be? So if it equals to 0, that means is even, right? So even numbers. So since we're adding individual elements to a list, what did we learn? We learned the append function. So we're gonna append the number to the even numbers list. So if it's not even, obviously it will be odd. So we don't really need to do like another condition anymore. We just know that's going to be odd. So odd numbers list and append that number to it. And then, so it's going to keep iterating through all the elements in the list until it reaches the end. So we can do this to give us the answer. Okay. This is outside the loop after the looping has completed and the two um lists have been done constructing. This is backslash in here. Second. Here we go. So we have a collection of even numbers and odd numbers from the list. So you can adjust the list as needed if you want to, but otherwise, this is it. Okay. It's been a lot of content today, but just we have one more thing. It's called functions. So a function is, I would say, like probably one of the most important parts when you program and structure your code. So function is basically a block of code that only runs when you call it. So you can pass data in for it to be processed. So usually, why would you have a function? So why would you have a block of code that only runs when you call it? So for instance, if you have a block of code that you want to use several times throughout your program, you don't want to keep writing the same thing every time you have to use it, right? So you would want to create a function. So every time this block of code needs to be ran, you just call it. Like you just like put, oh, use that function here, use that function here, use that function here. So it avoids repetition. Okay. So now we can go into how the syntax of a function looks like. So usually you want to define a function with the word def, like def for define, and then the function name, in this case is called my function, and with parentheses, and then colon. And then when you indent, everything inside of it is the function. So everything, like all the code that you need um, to be ran repeatedly or whatever is in the function. So for example, in my function, it just runs hello from a function. So we can try um running that just to see what it looks like. My function, and it did like hello a function. So let's see. Oh, it doesn't run because we didn't call it. So this step is only to define a function. To call a function, you just do my function parentheses, and that calls it. So that tells the computer that we need this function to be ran. So if I do that, hello from a function. Okay, good. And then, well, usually functions don't perform operations that easy. A lot of times you have to pass in something called an argument. So for instance, you want to say, you want a function to say your name, like hello, my name, no, like name, hello, like Tina, hello. But like the name can differ. You don't know whose name is going to be input. You can create a function by doing by defining a function, and the function name is say hello. And inside the parentheses, this is what's different. There is a thing called parameter variable. So the parameter variable, we name it here name. And then inside the function, we tell the we tell the function like what's going to happen to the variable name. And as we can see here, it tells to print the name plus hello. So when I call the function, I pass in Tina. So Tina is substituted for name, and therefore it will print Tina hello. Okay, does that make sense? That's a lot of like passing around stuff, but I drew some arrows. So basically, Tina goes to the parameter name, and name goes to name. Like name goes to everything that happens inside a function. So here we can, for clarity, we can do an example. Say hello. And the parameter was name, and inside the function, what we wanted to do is to say hello to that name. So hello, name. So either I can say hello, let me call the function to myself, Tina. What's gonna do? It's gonna do hello, Tina. Or if I didn't want me, like I wanted to say hello to Morgan, like I can change it, change the parameter here to Morgan, and then it'll change the output because it's passing in a different argument for the parameter name. Or I can change again. I can change on to Ian, and it'll say hello, Ian. So can change parameter and the output will change. So basically just summarizes why functions. So you can reuse code, like I said, to call it again and again, and it's easier to maintain. So when you have a long string of code, uh, and for example, like the same operation happens throughout the code. If you realize there's a problem with it and you need to fix it, that means you have to go through all the different cases and fix it individually. But with functions, you can just easily fix it in the function, and then everywhere else that calls the function doesn't need to be changed because it's already been changed in the function. And then clear structure. There, you can get a better like visual organization of how your thing works. Like for example, this part needs to be added, therefore you use the add function. And this part needs to be subtracted, you have the subtract function. So it's more organized rather than like a long page of code that you can't really read through. So that's pretty much on functions. Um, does anyone have any questions? I know like functions and loops both can be pretty hard to understand at first. There would definitely more of the difficult content that takes a while for it to sink in. But like if question arise at any time, you can just let me know. It's okay if you're not entirely understanding right now, because it is difficult. So if you have any clarifying questions, just please let me know. And yeah, and that's pretty much all the content that we're going to cover in this class. And then I will send out the homework to the group chat, either via WeChat or via email later tonight, and then you can take a look at it. If you don't know how to do it, it's okay. The instructor will cover it tomorrow morning. So if you don't have any questions, you are free to go. But if you do, you can stay behind. I'll be here for a few more minutes.